Assume that this is a thread. This one is a thread. You record here. Here the person is standing. Here thread. Okay. Here tied some stone here. End of the thread. Stone na tie ಮಾಡಿದ್ದಾರೆ. Okay na. You started revolving this thread around the circle. Okay. Around the circle you are revolving the thread. And because of why it was revolving here or okay, some amount of force is acting towards the center, which is called the centrifugal force. Okay, while you are revolving, while you are revolving, if you leave that force, if person leave bit up, if you leave that force, thread bit up, it will go from. If it was revolving like this, no, it was acting some velocity, acceleration. You know that, right? Yes. Velocity, acceleration. If any object is moving, it has some velocity and some acceleration, some motion should be there. Okay, in which it was moving in which velocity is there, no? If you leave that one, it will go off. Okay, if you leave here, this point if you leave this, it was revolving like this. Assume that it was revolving like this. Okay, in anti-clockwise. Okay, if you leave like here, means it will go like this. Okay, you are revolving like this. That thread you are revolving like this. Okay, in this point, if you leave that thread, it will go like this. Okay, in this point, if you leave, it will go like this. The line where you leave the thread, no, in that line where it will go off, this is called as tangent of a line. Tangent of circle. Tangent means straight line with some sort of velocity, acceleration, or some magnitude. It has magnitude. It has direction also. Here it is going with magnitude. Means almost to assume that 10 meters per second. Okay. With magnitude and with direction also. If you leave here means it will go like this. If you leave here means it will go like this. Right? It has direction also, magnitude also. Okay. Like that, like this. See.
You get. Hello.
Okay. See. Yes. Assume that in your previous, in your next classes, they will say I think almost. Okay. Here I have 5 kg of stone. Okay. Here I have paper. If I leave both at the same time, at the same height, which will go faster? No. It's completely wrong. We will assume like that only. See, Galileo, some other person, what he investigated means, see, I am not teaching chapter, but some stuffs I want to tell you. People will go forward and while you are studying, no, in that time you will realize. Okay. It will some metallic thing it will come, means the vacuum, it will call as vacuum. In that no air will be there, zero air. Okay, no air will be there, no moisture, nothing. In that vacuum, he done an experiment. Okay, he has taken 10 kg of stone, assume stone, and feather, you know, this reckon. He has taken both. Okay, there is no air, there is no moisture and all, and he leave that both thing at the same time, at the same height. Both will reach that ground at the same time. Not even a millisecond of difference. It will go at the same time. Here in the air condition, if you do that means, okay, stone will go fall and down very fastly. Because the stone is very heavy, mass is more, 10 kg of more, it won't affect any air conditions, stones. But feather will, feather will take off more amount of air, the conditions will apply for that feather, but not the stone. Right? Are you getting? Okay. It's not possible because what is the reason means the gravitation for every object it is equal. It won't distinguish anything if it is large, if it is small. No, irrespective of the weight, irrespective of the time, every object it was acting the same gravitational force. Due to some atmospheric conditions, it will varying. Okay, it will varying. It was varying so much. Due to air, feather, it was varying. For air, it was varying so much. Varying so much. There's some some formulas will come. Okay, in real life also you have to be experienced for the formulas, because I told that these two objects is having some certain of force, right? You have to know that what force and how much force is there in between these two objects. How you will find out? Okay, I am seeing. I don't know anything, but I am seeing in the blind eyes. Okay, in open eyes I am seeing, but I don't know, because the some amount of force I want to calculate means there is the formula. Okay, force is directly proportional. Directly proportional, you all know. Force is directly proportional to the. If you are finding the force between two objects, you have to know about the mass, weight. Mass is nothing but weight. Okay, you have to know about these two masses, these two object masses. Okay, these two masses. This is M1. Think, assume this is M1, this is M2. Mass 1 and mass 2. Okay, because force is directly proportional to the mass of the two objects. These two objects. Okay, these two objects, mass of these two objects, and inversely proportional to the distance. See, these two objects. The distance between what is the distance? Approximately 10 centimeter. Assume 10 centimeter, right? These two. Because okay, we will what in units. What we will measure distance in meter, right? Not in centimeter. You will convert centimeter to meter and you will apply the formulas, right? Okay. Assume that 1 meter. Assume 1 meter is there. The distance. Okay. Assume if you are willing to calculate 2 meters. Assume 2 meters. Okay. 2 meters by d square. Okay, distance between the two objects, because you have to find out the force between two objects. Okay, the distance, square of the distance, not the only distance. If it is 2 meters, you have to multiply with 2, right? Distance d square. In proportionality, mass, if the mass is more, the force of attraction will be less. The mass of these two objects is more, so the force of attraction will be less. The example is the apple is falling towards the earth, but now earth is not falling towards the apple, right? Because the mass of the apple is very low mass of the apple, but the earth mass is very bigger, so the apple is going towards the earth. If the mass of the earth is less than apple, earth will go towards the apple 100%. Okay, you have to take that in a practical way. Why apple is going downwards? Gravitational force, the force is between two objects, right? Why apple only coming towards the ground? Ground also should go towards the apple, right? The mass also it will very much mass also it will come to the come to the control while the force is acting. So the mass of apple, assume mass of apple, mass of earth, right? The mass of earth is more.